So good morning, Sweden, and hi, the rest of the world. It's an honor to be here today, talking about what we believe is quite important, that we try to make our vehicles more sustainable. I will give a quite broad introduction, talking about what's driving the development right now, but I will also give you some details about what we are doing, giving examples, and then I have contributions from PhD students that I've been have the honor to work with very recently. So let's start. What drives the development of lightweight composites solutions for the vehicle industry? Well, we all know that the amount of people in the world is growing, and the number of cars in the world is growing. And at the same time, we have the problem with the environment, that we have to take care of our planet. And of course, make sure that we reach the climate goals. And all the different parts of the world, they have actually set goals for limitations in their carbon dioxide emissions. The EU has a quite high demands. They want to decrease the carbon dioxide footprint with 40% roughly. It used to be almost the same in US. I don't know what holds right now. And in China, they're talking about 30% on an average fleet. So how do we meet those requirements? Well, looking at the spread chart of what causes the fuels consumption of a common vehicle, you see that they have the drivetrain, it's 42%, some friction, rolling resistance, aerodynamics, and then we have weight, which by itself directly causes 23% of the fuel consumptions. These are numbers from one of the automotive producers in the world. And of course you can look at it, it looks large to start with, but actually it's even larger, because reducing the weight reduces the rolling resistance. Reducing the weight also makes it possible to make a cheaper or at least lighter drivetrain. So there is a possibility of reversing the weight spiral if you look at it from the broad perspective. So what we would like to see is, of course, that you come with the future product, that we start making lighter weight multi-material designs of lighter chassis, which makes it possible to downsize engine, and we can reduce the fuel volume, and all of a sudden the total weight kind of just adds up to something even bigger. And this is where we are hoping to go in the future, of course. But if we want to change something, we also need to know from where and to what. And this is a picture showing the body in white of a Volvo car as it is today. And you can see all these different colors here. They are all different material systems, from aluminium to very high-strength steel and high-strength steel, ultra high-strength steel. A lot of different grades in different places, all optimized to give the best performance at the best cost, at the lowest weight for that specific application. So you see, we have something today for this main load carrying structures that is consisting of more than 300 parts. They have optimized it so it's very cost efficient. They have used it the best way they can do. So how do we meet these targets? How we make it lighter when it's already made as light as possible with today's solutions? Well, we have to, of course, start looking for other materials. And I work with carbon reinforced plastics or glass reinforced plastics. We call it composites. Normally comes in a shape of either long continuous fibers or chopped fibers. These are carbon fibers, so they're black. It could be glass, then it would be more white. They come together with a polymer resin that wet the fibers and bake them together into a product which can have a desired geometry and properties according to how we design it. These carbon fibers, they are very stiff. So with that, we can make something that is just as stiff as steel, but at much lower weight. It's lighter, it's stiffer, and it has high quality. The problem is that this is a material system that has been used quite some time in the aerospace industry, but that is a very manual process and very limited number of applications produced every year. Now, if we want to go to the vehicle industry, we have to step up the production speed. We have to do larger volumes, and we have to also meet with a high raw material cost. We have to meet these challenges that we saw in the previous picture with the optimized vehicle. So can we do that? Can we reach a material shift in the automotive industry? This picture you see here gives you a feeling for what it used to look like. We have on the Y graph the weight saving potential, and this is the state-of-the-art car. Here's a friend of mine who have mapped different designs that has come with the aim to reduce weight, and where the industry actually has said that it's okay to add more cost to the design since we gain so much weight. So like a geometrical design that costed a little bit more, and higher strength costed more, tailored properties even more, lighter hang-on parts cost more. So for each improvement here, you could save weight, but it also increased the cost. And seemingly, it's like a lightweight corridor here, so to speak, where we have to stay, which we have to stay close to, which is almost in the range of 10 euro per kilogram saved weight. So this is what we have us to play with. Looking to the very left there, we see that what a carbon fiber reinforced body with a low productivity, small production car, where we have that. And you see that's quite far away. This is the travel we have to do. So how do we do that? Well, people normally point out that there are three things that needs to be done. Either you start working, or you have to start working on the cost and weight optimization. Everything in the vehicle is optimized, and aluminium, steel has been around for such a long time. We know how to do this. We know how to produce for these materials, but we don't know exactly how to produce large-scale volume manufacturing for composites. So we have to start from the beginning, thinking in a new way, designing in a new way. We have to look at new materials and processes that compared to what the aerospace industry use, of course, because that's a different field. So that has to be developed. And of course, also multifunctional materials and structures, where you can, for example, as you will see in the next talk, maybe make a car roof that is both a battery and a structure at the same time. So stay tuned and you will hear. I will talk a little bit about the red points, the first two ones, because that's where we've been working here at KTH. So starting with the cost and weight optimization. So we had a project together with the Swedish automotive producer, trying to figure out if they were to change from metal to composite, how would they do it? You think that the composite is one material and one process, but it's not. It's a lot of different materials, and depending on which material system you choose, you have to take a certain process, and with each process there comes a certain feasible production volume and production time. So depending on what the structural requirements are on different parts, maybe here we have some crash zones where we could have stiffness requirements. We have a roof that you should be able to roll over on. Depending on what the mechanical requirements are on different parts of this body in white, we have to select the best material system and process from a weight and cost perspective. So that's how you start a holistic approach. So then when you know which parts should be in different materials and processes, you have to define how many subparts are optimum to do. With composites, it's possible to make really big integrated components like this. This is how the aerospace industry works. But from a cost perspective, it's probably not efficient because the machinery has become so big. So in the end, it's not good. So then you need to define how, from a complex perspective, if we have a complex component like this, is it better to divide it and how much? And if we should divide it, where should we divide it? Should we divide it so where you have a very weak zones, or should we so we can have like overlap joints there, or should we divide it to simplify the geometry and make everything easier to handle? This is a framework that was developed together with Volvo and was very interesting to follow, and it gave us a path to continue. Just to go into this cost and weight optimization, because we have stayed there for also other structures. This is a picture with a lot of information, but what it actually tells us is that composites in large scale is starting to become common in the world, and when it's available, we can know what it costs. But we are comparing with metal that have been known for such a long time. So now we have to, if we want to start designing for and in composite, we have to start like predicting in the future what can the process do in the very end. So we have to look at the manufacturing process, the store. It could be a lot of different steps here. It's like a press forming operation. We have to list down the time and space and it costs everything. So we know how much it costs to produce a component when you have a certain amount of material, certain geometry, etc. And then at the same time, you have to do an optimization of your geometries, seeing if I choose one material system, do I have to have a lot of material or less material? If you have more material, this part will be more costly. And then you have to balance all this. So this is the cost and weight optimization that I think will be one of the keys to understand how to continue in this path in the future. The next point I was going to talk about is this new materials. We talk a lot about composites based on carbon fiber because that's kind of like fancy. But it's also important to remember that if we go for a more environmental approach, we can't just choose a material system that requires a lot of energy to produce. So we have to look for other options. And one potential, which is not comparable to carbon fiber, but could be used in some of these subparts, is a self-reinforced polymer composites. This is a material made of PET bottles, you know. It has fibers, as the other materials, out of more crystalline fibers, crystalline PET, and it has also fibers out of amorphous PET. Amorphous PET melts a little bit sooner. So what we can do with this is that we heat it up, the amorphous fibers, they melt, and the crystalline fibers, they're still there. And we have a composite that consists of only one material, it's PET. This is thermoplastic material that can be melted, so that is also good, and easily recycled to something else. This is a material that is not that as good as I said, as carbon, for example. You can reach soon the level of glass, but you can produce it with some support structures to make it efficient. And as I said, we have a possibility of recyclability, low density, and also it has higher ductility. So for some places where you need this ductility, it's very interesting to go for this new material system. I also want to point out that new materials doesn't have to mean really new. It can also mean that you take your used material and use it once again. Up to today, carbon fiber composites hasn't been around in such amounts that it's been, for practical reasons, been possible to recycle. What people normally do is that they grind it to some filler material and mix it with some resin. But this material, it looks ugly, I'm sorry. But this material has been in my bag since yesterday. If you have a carbon fiber grade for the aerospace industry, for example, you can, with the techniques today, recycle it and regain almost 100% of its mechanical properties. And the recyclability, the way you recycle it is to take away the thermoset resin. That cost is less than 50% of the cost of new material. So if we can have a market where the aerospace scrap goes into the next industry, and that we can start recycling and taking it into further steps. All of a sudden, the material system that used to be very expensive is not as expensive. You can sell your leftover products, and you can buy less already used material that has really good mechanical properties. So this is also something I'm hoping we can see more of in the future when the volume goes up. Also talking about new processes, since it started with the automotive vehicle, now aerospace industry, sorry. This aerospace industry, they have actually developed a lot of robotized manufacturing lines during the last 10 or 15 years. And we have to continue this process. And perhaps not only working with robots together with humans to produce composite in an efficient way, but also combining these different processes, press forming one part and then making another geometry on top to stiffen it up, but with a different equipment. So this all together gives us a new variety of processes that we can combine and give us cost efficiency. And then, of course, I would like to point out that the key to this is to be able to understand how the process works so we can make it stable and robust. And, of course, it's very important with process simulations to support design so that when you design a component, you need to know, is this deformable? Do we have a material system that deforms the way we want so we can easily press it into the right shape, or do we have to have some other properties of our material system? So the simulation outcomes, they give us gives feedback to the material suppliers and help us selecting the right material system at the same time as it makes the process more efficient, it makes it more robust and less waste. So this is also important that this goes hand in hand with the rest of the work. So to summarize, I think we can say that weight reduction is important. We don't want to be in like bandwagons on the street. So, and composite materials gives an option to step up and take a new development schedule in the vehicle industry. We have the cost targets to fight with, but I think it's doable. But of course, there have to be more infrastructure around this, and especially around recycling. I would like to stress that we need to use our materials more than once. And of course, we need to find new, improved fiber material systems as well together with this. Cheaper and more having good properties. So is composite materials a route towards lighter, more cost-effective and sustainable vehicles? I would say it is. Maybe it's not the only solution. I would expect that in the future we see this spreadsheet, this body and white picture with all the colors, that we bring new colors, which could be composites. And I don't think composite will be in all the different places, but it will be in some of the places where they fit the best, and in other surrounding structures, of course. So that's what I had to say. Thank you for listening.